In this video, we're going to learn how to solve story problems with trigonometry and Pythagorean theorem. There are some steps you need to go through after you read the story problem to help you kind of get to the final answer and then create your sentence at the end. First, after you read it, is draw a picture. All of these problems are going to have right triangles in them, so simply draw a right triangle. Second, label the known values, the information given to you. Third, determine what you need to find. So what are you actually solving for? Could be a side or could be an angle. And the fourth step is figure out which of the following you need to use. We're going to focus on trigonometric equation and Pythagorean theorem. Trig equation has two sides and an angle inside of it, the trig function. And Pythagorean theorem has three sides involved in it with it. So you cannot use, for example, a Pythagorean theorem equation when you're given one angle and one side. And likewise, you couldn't use trig if you were only given two sides and asked for a third. Because, for example, just a reminder that sine, or like trig, sine, cosine, tangent, sine of an angle equals side over side. If the problem gives you two sides and asks for a third, there's an angle sitting here. It's not going to help you find a third side. Pythagorean theorem is a squared plus b squared equals c squared, or side squared plus side squared equals another side squared. You have three sides here. So if the problem gives you two, you can find the third using Pythagorean theorem. So you have to decide what's the given information and what's being asked of you, which equation to use. After you set that equation, you just simply solve it, and then you're going to write your sentence at the end. Some things to note, in terms of right triangles, you're going to have a right angle, a horizontal side, and a vertical side. Things that commonly appear on the ground, shadows, walkable distances, those will all be in the horizontal part of the triangle. Vertical is mostly going to be height, vertical height off the ground, distance above the ground. Those are going to be your vertical side length. Then your hypotenuse can be anything from a wire hanging from a post to the ground, to a lot of other things going on. Distance from the ground up to the pole. Just depends on the problem. It becomes easier to talk about after you draw a picture. So let's go through first example. This says a tree casts a shadow of 21 meters when the angle of elevation to the sun is 25 degrees. Find the height of the tree to the nearest tenth of a meter. All right. So first draw a picture. Make it a right triangle. Label the known values. A tree casts a shadow of 21 meters. Shadows appear on the ground. So 21 meters would go on the horizontal side length, here to here. Angle of elevation to the sun is 25 degrees. The angle of elevation is going to be from the sun or the ground going upwards. So this is going to be your angle of elevation here. How far up does the hypotenuse have to come from the ground to get up to the sun? Then it asks, find the height of the tree. The height will be the vertical side length, which we'll call x, but any variable will do. So you're tasked with finding this side length, given this side length and this angle. It should be clear at this point that we're going to have to use trigonometry because Pythagorean theorem involves three side lengths, and we only have one here. So we'll solve it for a second, giving an angle. So the x is the opposite side length. 21 will be the adjacent. Therefore, we have to choose tangent of 25 degrees is equal to opposite over adjacent. And in case you need a refresher on the trigonometry equations, go ahead and go back and watch those videos. Cross multiply. You're going to have x equals 21 times tangent of 25 degrees. To simply calculate 21 times tangent of 25 degrees. And you should get x is approximately the nearest tenth. I got 9.79, so that's going to be 9.8 meters. So the sentence could simply be the tree is approximately or about 9.8 meters tall. Just a simple sentence stating you know what you're talking about in terms of the final answer. That's it. Number 2 on the sheet. A large totem pole is 120 feet tall. On a particular day at noon, it casts a 185-foot shadow. What is the sun's elevation at that time? So what is the sun's elevation at that time? Round to the nearest tenth. Draw your picture of the right triangle. 120 feet tall, label that here for the vertical length. Shadow, 185 feet, is going to be down here on the ground. Sun's elevation, that's going to be your angle of elevation right here, which we'll call theta, or you can use phi, doesn't matter. So you're looking for theta, the angle. So again, we're going to have to use trig because Pythagorean theorem does not involve any angles whatsoever. 120 is going to be our opposite side length. 185 is going to be our adjacent side length, making this tangent again. So tangent of theta is equal to 120 over 185. So inverse tangent on both sides. And the reason we do this is because we want the tangent to be canceled out, or to undo this tangent. That way you get theta completely by itself. This you type in the calculator, and we do the second button, the blue button, then tangent for inverse tangent. So inverse tangent of 120 divided by 185 will get you 32.96. It's actually going to be 33.0 degrees, round to the nearest tenth. So a sentence could be, the sun's angle of elevation is 33.0 degrees. Okay, let's try one more. Number 5. Number 5, we're looking at a ladder leaning up against a building. A ladder is 25 feet long. It reaches 18 feet high. On the building, how far away from the building is the base of the ladder? That's question 1. Question 2, question 1. Round to the nearest tenth if necessary. Okay. So we have, again, our right triangle. The ladder is 25 feet long. That's the hypotenuse, actually. The ladder leaning up against the wall, that'll be your hypotenuse. 18 feet high is your vertical side length. And then it says, how far away from the building is the base of the ladder? Not an angle question. This is actually asking for another length. This length right here. How far away is the base of the ladder from the building? Being that this is the building over here. Okay. So we have 3 side lengths, 2 we know, 1 we don't. That's going to involve Pythagorean theorem. Remember that A and B are your legs, C is your hypotenuse. So you're going to put in 18 for one of your legs, X for the second leg, and C will be